Okay, at the contributor meeting, somebody was like, hey, why don't you build a circuit daily and post it? And I was like, I wanted to do that. And I think it's a great idea. Why am I not doing that? And the reason I'm not is because we're probably going to run into bugs as I do it. So let's try it today, and I'll post every day until it works. So if I post this because I don't think I think it's valuable. So let me pull up everything I need to pull up here. Okay, cool. No Twitch chat today, so let's turn that off. This is just a recording. Okay, so I'm gonna get started. I like to develop directly against the CLI when I'm building a circuit a lot of the time because it's a little bit easier to pull in the latest versions of the code if I do find a bug or something like that. Let me swap where my terminal is here so that's a little bit easier for people to see. Okay, and then let's see, do I have an open PR, fix dev command? Yeah, we might as well merge this guy. Oh, we got merge conflicts. Let's see. Okay, so I'll fix this merge conflict partially because it'll be fun. It'll be fun to show how we fix a merge conflict when this stuff happens. Okay, so we have a merge conflict, and it's saying we have a couple files, and one of them is a log file, one of them is package.json. So for package.json, you do kind of have to resolve these manually. So I'm gonna do this. There's a lot of ways to resolve it. VS Code will kind of walk you through it, but in that case, very easy. The merge editor is really, really great. So I'm gonna save that file. Now for the bun lock, you just do bun I, and it'll auto-resolve. So you don't really have to worry about that one. We're gonna do git commit and merge, done. Okay, now it's passing. We're gonna squash and merge, fix dev command, awesome. I've created this issue, simple 9-key keyboard in example project directory. This will be a good circuit for testing that the CLI works properly. So this will be the circuit we create today. If you're not familiar with the CLI repo, very easy to use. First, I'm just gonna pull the main branch. I have that aliased on my system. Whoops. Let's clear my terminal here. You just run bun run dev. There's really not much to it. Bun run dev will build everything and make it work. So we're gonna do that. And then I can go to localhost 3020 and the circuit should pop up if they built properly. It looks like there was a problem building one of them, which we can investigate. But yeah, there's some issue there, but basic chip built. And you can see it's not rendering properly in the schematic view, but the PCB view actually does render and route. It's just some of the stuff isn't fully working yet. I think this is supposed to have a manual placement. So let's look at, let's look at the source code and let's try to figure out what's going wrong with this. So it's inside example project. We have basic chip. And I know that's the name because when I look up here, it says basicchip.tsx. And we can see we have some manual PCB placements. If I go inside of this, I can see that we have some manual placements for these components, but these don't look like they're getting applied. The center of U2, which I think is this guy, U2, is not, it's at 0. Everything's at 0. So let's see what's going wrong with this. Let's see if we can fix it. The first thing I'm gonna do is with this kind of bug where the soup or the generated files aren't generated properly, you usually want to update tscircuit core. That's going to be the main way that we fix these now because that project is being actively developed and has lots of fixes all the time. So let's pull that and see what happens. And we're rebuilding. By the way, most of that time is spent building the front end, not like anything else. So that's why it takes so long. So it looks like it is not working, which is kind of weird, but not the most unexpected thing ever. So let's open up core. I like to do a quick version. Oops, forgot that does that. I like to do a quick version check to just make sure I'm using the latest version. So when I did bun update, I think I got the latest version. Yeah, core. Yeah. So I'm running the latest version over there. Let's pull main. I don't know, maybe we're missing. I'm just gonna check for any merged PRs to see if everything got in. Fix for issue 22. This is old. We'll close this. This is an AI PR. You might see a couple PRs created by tscircuit bot. There's an AI that can do some PRs. Okay, so why isn't the manual placements working? Let's dig into it. Here is a test that tests the manual layout prop. Usually tests are pretty simple. You only really want to test one thing. So we're creating a board, we're putting a resistor and a capacitor in it. We have these PCB placements with selectors and center, and then we're expecting for the positions to change accordingly, right? One thing that this project doesn't do is it doesn't really look at the generated soup to make sure that the soup is placed properly, right? To make sure that the circuit JSON has the correct X and Y positions. So that's one way to extend this test to make it maybe a little bit better and reflect what we're seeing in reality a little bit better. So we might as well start with that because I can't really think of what could be going wrong here. Like when I look at we have basic chip manual placement, whoops, and then we have our manual edits here. It looks like it's in the right format. There's no edit event ID, but otherwise it looks like everything is correct. So it's basically the same code. Layout, manual edits, right? Layout. Oh, this does say manual PCB placement. Okay, and it has rebuilt. Let's see. No, we're still not working. Yeah, I was like, those probably do the same thing. It's also possible we need to update the tscircuit layout, although I kind of doubt it, but we can do a quick version check just to see if there's some kind of version issue there. 0.28, and then versus the one we're testing against here, /layout. 0.28, so they're the same version. So let's take a look at the generated soup file, the circuit JSON, and I'm just gonna filter it to elements where the element type equals, let's see, PCB SMT pad, because that's the one, those are the blocks. We're seeing each of these as an SMT pad. So it does make the position a little bit harder to think about, but for those blocks, yeah, I mean, actually, this could be the issue. Now that I think about it, I have a feeling this is probably the issue. Circuit JSON, PCB SMT pad. I'm trying to think of how we can test this because we know this position, it's really small text, but in the bottom right, I can see the position is -1.5. So if I go from here, -1.5. So we know that, so you know, I might be able to, sorry, I'm just like thinking about how to test this. Let's get the position of the SMT pads, but not in the soup, even though that's a really good test. Let's do select all, and then let's do R1. I think I can do SMT pad. And we'll just say R1 SMT pads. And let's just log that for now. So I have a lot of hotkeys set up. One of them is to run tests when I just hit a hotkey. And I can share that, but you know, I'm just gonna keep hitting that hotkey to run my tests on the right. I realize this view is a little cluttered. Okay, yeah, there we go. That's my hotkey. So we've got these two SMT pads. What is the position of them? We know that the location, yeah, it's not right. It's not shifted by 5, right? So I think I know what the issue is. I overrode this position, get global PCB position, to incorporate manual placement. But what I didn't do was override. There's two functions. It's kind of confusing. There's two functions, but there's there's get global something else. I think it's PCB transform or something like that. Yeah, it's compute PCB global transform. And this is the one that's actually supposed to shift things, and that's how children get shifted. So this one should really not be overridden. You really don't want to override this function. So we're gonna take this, or you don't want to change this function really. We're gonna take that code. I realize this is confusing. Get global PCB position gives you the center of a component. Compute PCB global transform tells you how is this component shifted and how should its children be shifted. It's a very subtle difference, but yeah. Working with transforms, it's just something that whenever you're doing visual programming is really helpful. So you just have to get really comfortable with the idea that there's always a transform behind any position, and you're not going to add together positions, you're just going to use transforms. So this is the transformation matrix that computes all parent transforms for PCB components, including this components translation and rotation. This can be used to apply, or this is used to compute this component's position as well as all children components positions. Okay. Whew. All right. So right here, compute PCB props transform. What this does is it computes a transform due to the property set on this. So we'll say, this is pretty interesting. Compute PCB prop. I almost feel like we should be modifying this one. Computes from the props of this component. I almost want to rename this. Compute PCB props transform. It's almost like compute PCB props or and we can make this underscore because it's very internal. Compute PCB props or manual placement transform. Is that right? No, I can't do it that way. Can't do it that way. Compute PCB global transform. I think we have to choose in this function how we're going to combine the manual placement with the props. So we got to do a bunch of transform math, unfortunately, and that means combining some things together. So I don't know how I do this. I always set off to do a live stream that's really simple, and then I always end up in a live stream where I'm doing some tricky piece of math. But yeah, I don't know how to prevent it. I think the thing is if you have a manual placement, you want to override the translation. We have to think about precedence. So should you apply props and then apply manual placement, or should you apply manual placement and then have props override it? I kind of think it kind of feels to me like you want to have the props override the manual placement. So we might want to say, okay, manual placement, and let's just keep it super manual, and PCBX is not equal to undefined, and props dot PCBY. We'll just say either. If you have a manual placement and you've defined one of these, let's throw an error. Both manual placement and PCBX/PCBY is defined. I kind of think your PCBX and PCBY should just override it though. Okay, so let's say PCBX or PCBY will override the manual placement. So if we have a manual placement and PCBX is equal to undefined and PCBY is equal to undefined, then we're going to compute a matrix where we use the manual placements as our X and Y. And we also have to compose that with a rotation if there is a rotation. It's where things get a little tricky. So compose, rotate, PCB rotation. And we don't currently have a way to do a manual placement with a rotation. So that's fine. And then Do parsed props. Okay. Wow. Hooey. Yeah. I don't know. Let's find out. Okay, it worked. It's funny when stuff like this works first try. So how it worked, so I know it works because now these are around 5. Before they were around 0. If I remove this line, well, the whole thing fails apparently because we're not applying, because now everything would break because I changed a different function. But yeah, they're about meaning around the position 5. So that means that it worked. If we were to do, instead of R1, if we were to look at C1, it would be around -5. Although I'm a little confused why it's like not perfectly around -5. I don't know, is this rotated? Oh, it's an 0603, so maybe it has a slightly different center. Although that positioning looks a little, oh no, that's right. It is symmetric. Okay, so we have the SMT pads. We're gonna just say expect let's say this, positions, and then we'll add this map line, and then I'll say expect R1 SMT pad positions 0.x to be close to -5 by 1. Or actually, this one's +5 because it's R1. Okay. All right. Oh. Received 4.5. What is this to be close to? To be close to expected number of digits. Oh, that's an accuracy thing. Okay, well, we will do it a bit manually then. Oh, but the order isn't really guaranteed here. So let's just say -5, -5, and we'll take the absolute value. So we're just taking the distance from 5 because I don't want to worry about the exact size of an 0402 component. Let's just delete this for now. And we'll say to be less than, it's like 1, you know what I mean? So really just a ballpark estimate, but it does validate that our fix is correct. Okay, wow, all right, so 1 bug down. Fix manual placements, not moving SMT pads or any children. Yeah. And also, this is a much better place to use snapshot testing. If we had used snapshot testing, wouldn't have seen any issues here. I could refactor this test to use snapshot testing now. Maybe I will. Manual placement, manual place 1. Just give that a random branch name. Let's add snapshot testing. Project dot get circuit JSON. Ooh, expect get circuit JSON to match PCB snapshot, import.meta.path. You have to do the import meta path because Bun is missing some features. Okay, so now we should have a snapshot. Let's take a quick peek at that snapshot. Make sure everything looks okay. Yeah, okay. So our manual placement changed the position of these two things. Another step we could add is to make sure it routes properly. But actually, I do want to keep this test simple, so we'll just do that. Let's create a PR. Okay, our PR is passing, checking size. There's really no difference in size, so we're going to merge it. So after we merge, this will publish a new version of core. We can integrate that into CLI. If you're working locally and you don't want to wait for merge, you can use Yalk. So I could just do Yalk publish, and then in my other project, I could do Yalk add. So that's how you work if you're not merging. I actually like to take pauses to review other people's work. So I will just wait for the new version, but I would really recommend people use Yalk just because this does take a lot of time. It takes you out of a flow. If you're using Yalk, you won't have to get out of your flow just to wait for something. Let's see. Okay, we've got our new version of core. Just waited for that commit to come in. So I'll update latest, and I'm gonna failed to resolve. I think I forgot there we go. Cool, we have the latest. Let's try our bun run dev, see if it works. So this should place our components so that they're not overlapping. if this works properly. Okay, I don't think it worked. Let's see. Yeah, it looks like it didn't work again. I did modify this file slightly, so maybe we revert those modifications and see if it behaves any better. We can see it rebuilding right there. Still nothing. Let's see a while. We can run some tests and try to get deeper into this by trying to run the server with a no cleanup flag. No cleanup. What that'll do is keep temporary entry points around. Temporary entry points are files you can run, and they kind of help you along with the process. So if this worked, it didn't work, but here's an entry point for the capacitor. You can see it's really basic, but I don't think it's working because, oh, maybe it is actually. Let's give it 1 second. There we go. Okay, so here's our entry point. So this is the code that's being run, and because we know the exact code that's being run, we can actually close out the dev server now. By the way, sometimes the dev server does this thing where I've like lost my cursor. There we go, got it back. So if you lose your cursor, let me know. I don't know if that happens to other people, but I lose my little command line cursor. So we can actually run that file now. So if I go to example project, examples, a basic chip entry point, you can run those entry point files and they'll write, or they're supposed to write, a JSON file somewhere. Example project examples, basic chip temp output JSON. You know, I don't see it. Well, it's definitely being produced, and it shouldn't be being deleted. So it could be an issue with, oh, there it is. And then let's add those to our git ignore. Okay. So now we have our soup output, kind of like the sort of compiled circuit. If I save this file, it might format. Yeah, so now it's a little bit easier to read. See, we got a bunch of PCB traces, PCB SMT pads. There is a debug server that lets you view this stuff, but it's a little bit non-functional right now. The table viewer, which is really the best viewer for this. So unfortunately, we can't use that. I'm gonna try to get that up and running again, where you can just paste these soup files and debug. But anyway, what we're looking for right now is to see if, actually, I don't even know if we need anything here. Why did I do all this? I'm just kind of debugging to see what is possibly going wrong. Because I almost don't believe it's not working. It really seems like it should. So maybe we have like some out-of-date data or something, or like an out-of-date module being used. Like what happens if I do bun update latest core again? It's version 28. I don't know. Maybe it just doesn't work. I'm in denial. Here's a bug for you. Okay. Post that to the Discord. Why not? Bug. New easy bug. Okay. Yeah, I'm just really surprised this isn't working. It feels like it should. Uh-oh. Component size is also not properly calculated. Yeah, look at that. That's where that bug comes from. That's component size not being properly calculated. Yeah, it seems like... All right, let's get a little deeper. Yeah, I think we have to. I just can't find a discrepancy. It looks totally fine to me. Like PCB placements as an array, manual edits. Let's check. And then in the snapshot too, we could see that the positions changed. So the soup here is correct. R1, C1, selector. I don't see any major difference other than the edit event ID, but okay. So when you have a bug like this, there's a couple things you can do to like the best way is probably to add tests. So try to bring all of this code, or as much of it as possible, to reproduce the bug. Like I could copy all of this out. Oh, maybe this is it. It's a board with a group inside of it. Oh, that's totally it. I just realized that. Yeah. Because core is pretty finicky about So for this to work, we would have to say subcircuit. That's totally it. Yeah, there we go. Oh my gosh. All right. Yeah, there's this new concept called subcircuits. Wow. Oof. Okay. Man, was really spinning my brain on that one. Let's add a little bit of validation logic either to Zod. So we could add it to the props repo. Do we have a group? We have a group component. So right now it's kind of phrased like this, but actually there's sort of two groups. Really, I'm almost wondering if it should be separate components like subcircuit and then group, rather than have it be a property of a group to be a subcircuit. It's kind of hard to say. But if a group has a prop called subcircuit, then you can have a layout. You can't have, basically within a subcircuit, everything, like a subcircuit can lay out and stuff like that. Non-subcircuits can't lay out. So a subcircuit is like a pretty meaningful thing. I'm debating, should we just have a new class for this? Because other people will get confused the same way, or I can add validation logic to group props. So to do it with validation logic, which I think might be okay, we do this, and then, or actually probably the best way to do this is we can say subcircuit group props extends layout props. It has subcircuit true, and then we could have base group props. Yeah, this is probably the best way to do it. Okay. Sorry, I'm trying to think of the best way to type foo this. So we could say subcircuit props or base group props. Base group props is going to have name this. Okay. Yeah, we're getting there. Subcircuits are really powerful. Okay, base group props, subcircuit, you don't have layout, you don't have routing disabled. Subcircuit, this is redundant. Okay. So if you have subcircuit true, you're allowed to put these props down as well. And that means we have to extend this. So we say base group props is this. Subcircuit group props is base group props. Extend subcircuit is a literal. You are allowed to define layout, and you're allowed to define routing disabled. When we look at the board, a board is automatically a subcircuit, and it looks like it defines stuff manually, so that's fine. But a board is technically a subcircuit. Oh, okay. Wow, that was a lot. Oh, and then we have to say group props is equal to a union between these two things, and we're getting a type error. It's saying they're not equal, so this is going to be a tough one to debug. But basically, we have to figure out why these inferred group props are not the same as these ones. When you have a type issue like this, the best thing you can do is, and this should not be exported. So we say type inferred, so that's fine. Inferred base group props, but it should really live up here maybe. Or we could put it all down here, all the type inference checking. Okay, expect types match. Oh, false. I don't know why. Oh, it's a dumb, okay. We're just writing a type checking test right now. Complicated. So we want to check first that our base group props are the same as our inferred. So that's not passing. So that's problematic. And then our subcircuit group props is the same as our inferred subcircuit group props. Okay. And those aren't the same either. So let's figure out what's going on. So problem one is this interface does not match this. I think it's because of the missing subcircuit, but let's actually remove this. Okay. Okay, so base group props is checking now. Subcircuit group props, subcircuit true, Z literal true, routing disabled, Z boolean. Seems fine. Subcircuit routing disabled, layout, seems fine. They seem the same. Oh, this should extend base group props. Okay. All right, and we're good. Wow. Okay, so now we're validating against this type issue in the future. Okay. Yeah, that was intense. All right. Let's commit that. Introduce group props. So just preventing somebody else from making the mistake that I made today, because it's a very easy mistake. Okay, all of our checks are passing. So let's merge that. And that will fix the type error over here where it says we don't have subcircuit on group. And also, if the bug was that I didn't have subcircuit there, the runtime bug was that. So now this should be impossible after this update, because you are not allowed to have layout if you don't have subcircuit, so nobody can make that mistake of accidentally there. Let's update that dependency. We got the latest version, and then we save, and yeah, we have a different type error, but it's not the same. Whoops. Okay, bun, run. Okay, so manual placements are clearly working now. It looks like the PCB component position isn't calculated properly though, because the drag, which is determined by the PCB component size and position, is not working. So we'll fix that in a sec. But it does look like I'm able to drag it if I can figure out where the box is. Looks like, yeah, the boxes seem to always be quite wrong. So we'll fix that next, and hopefully that gets us a little closer. It's crazy rewriting all of this after it was basically working with core, and then we're just taking a step back and making the code better, and kind of like going through the whole process of almost writing all of tscircuit over again. But I guess that's what it takes to get good quality code. All right, I'm gonna check out main using my little shortcut. And what we're trying to fix is the PCB position. So I have a feeling we wanna start in the primitive component, because that's where we calculated all of our transformations earlier. And then somewhere in here, I think it's gonna drop a PCB component. Okay, I'm wrong. Normal component, do we drop the PCB component here? Okay, here's where we do it. Do initial PCB component render, center equals, and yeah, it's just pulling the position from the X and Y there. All I need to do is swap this out for get global PCB position, and that should calculate it. You can see that width and height are supposed to be calculated in the PCB analysis phase. So let's go to that phase, do PCB analysis, and you can see it's not really computing anything. So what we'll do is we'll compute the width and height here. And the reason I think it's not done here is because none of the SMT pads have rendered. So let's compute the... At this stage, the SMT pads / PCB primitives are placed, so we can compute the width / height of the component. Okay. To do this, we can just iterate over the children. Then we can do a min-max algorithm, or so we'll say min-x is infinity. This is like a very standard way to do this. So the reason you set these like this is because they will be overridden by the next math min, math max. Saying is PCB primitive, we get the X and Y, and then we compute all the min X, min Y, and then we calculate the width. So now we have the width and height. Now let's modify the PCB component like that, and we're done. Okay. Now we need a test that makes sure that this was computed properly. So let's write a quick test. So let me just add we'll do PCB analysis is what we'll call it. I also need to make sure this phase is actually, yeah, it's literally the last phase. Okay, I think PCB analysis is kind of a bad way. Is this stuff, or a bad name, excuse me. So let's rename it before we get too into it. So it's called PCB component size calculation. We'll just be super explicit. Okay, great. Technically, you can also recompute the center at this point if you wanted. You could compute a new center for the component, because this center is not really guaranteed to be accurate at this phase. So it's not a bad in the PCB size calculation. Yeah. Not a bad idea to recompute the center, but because it's just the average of the max and min. So yeah, we'll see. We'll see when that becomes a problem. Most of the components we place are actually symmetric. So yeah, it's not really clear if that's going to be a problem yet. Okay, so rename render phase, rename PCB component size calculation phase. And then I think that I also captured my last PR, or my last little thing in here, which was, oh, actually, so yeah, we basically just added the, okay. Cool. I'm gonna use Aider to help me write a test. So we're gonna add the lib, add tests. Please write a test that has a resistor. Yeah, let's do a resistor and a footprint 0402, and is designed to test that the output PCB component size is correct. We're testing the normal component do initial PCB component size calculation, but don't directly call it. Prefer the style of existing tests. Normally I don't give a prompt that long, but I don't know. This is gonna cost, I'm guessing this is gonna cost like 10, 12 cents. One of the problems is with the Aider context is I'm sending in a bunch of useless SVGs. So I sent it a lot of extra stuff. Okay, looks like it did it perfectly based on what I'm seeing there. 17 cents, okay. We do wanna create that file. Run the test command, sure, test it. Okay, it failed, but I'm gonna manually debug that. I just wanted it to bootstrap my new test. Just gonna run git status to figure out where it is. Resistor, PCB size test. Okay, let's log it. We're gonna run bun, test, path to test. It says it received 0. PCB component size calculation. Renderable PCB component size calculation. Okay. Just say if not, PCB component ID return. Okay. I'm just gonna add some stuff to make sure we're getting here. PCB component with height 0, min x, min y. So we'll log the xy of each child. Oh, okay, so what this comes down to is we also need to get the bounds of the children. So you actually need to offset by the width and height. So it's something like, yeah, child.get PCB size. Which is super similar to this one, except for PCB primitives. Yeah, it almost makes me want to like restructure this a little bit, but this one is going to be available to primitive components, so it is a little bit different. Okay, we'll just introduce a new function, get PCB size with height. If not, this dot is PCB primitive, we're just going to throw new error, component is not PCB primitive. And then we'll do, yeah, we can start with this. If props dot, yeah, there's a lot actually. We have to handle a couple different conditions. So I think what we have to do for this is actually implement this like inside the SMT pad and stuff like that. So actually, I'll probably throw an error, get PCB size is not implemented for this dot component name. And then we'll go to SMT pad and we'll implement get PCB size. And now we have type checking. It's just a lot nicer. Could not, yeah, we can do unknown shape. For shape, shape not implemented for this guy component. Okay. Yeah, it's like, hey, shape doesn't even exist, but this is more of a runtime check. So, okay, that should work. For plated holes, we're gonna have property outer diameter does not necessarily exist. I wonder what's going on here. So what do we have? We have shape again. So if props.shape is equal to circle, and then if props, and then we'll do the same thing here. Okay, and then here we'll do I kind of like the idea of calling this like outer bounds or something rather than get PCB size, like get PCB outer bounds or something like that. But anyway, that's fine. Yeah, that's good. That took a while, but we should be in a good place now. Let's run it. I kind of forget everything. We're doing a lot there. So, okay. So yeah, we've got these logs that kind of indicate what we're seeing. Oh, right. Okay. We're almost done. So we got the width and height. Now what we need to do is say, yeah, it's already kind of getting ahead of me. Plus width, minus height, plus height. So now we're incorporating, oh yeah, these all need to be divided by 2. Assuming it's centered. Always assuming things are centered. Okay, cool. So we received 1.6. So these are looking like the correct values. If we look up in 0402 footprint diagram, we can probably get a sense. It looks like, yeah, it looks like 1.9, 1.6. That's ballpark correct. Let's go to our test, and I'm going to be really lazy and just copy out what it says. 1.6, 0.6. So that's like kind of a snapshot. Okay, cool. Let's make sure we got rid of all the console logs in our code. There's one there. I think the other ones are not relevant. Yeah. Okay. Maybe even intentional. Okay. Correctly compute PCB component size. That was a good one. That was a good PR. Okay. Oops. Why isn't this opening? Go. I'm gonna push pause on this part. This will get merged in, and we'll see that drag and drop hopefully get better. But I'm gonna push. It looks like a test is failing too. All right. But anyway, I'm gonna push pause. I'll probably fix this test and push this up. But yeah, I'll probably record another video of today. I'm gonna keep trying to build out this keyboard, and every time I run into a bug, I'll go and fix the bug. So we'll see how long that lasts. But yeah, thanks for listening.